So now let's see how we can use some of the things we saw for Pandas and Matplotlib and how that applies with RMSP to get to a desirable output. So let's specify some cutoffs. In this case, I'm going to be specifying cutoffs for background. And this is kind of like domains, if you think. So low grade. Cutoff for low grade, let's use 2. This should be a column. And high grade, it's gonna be 4. So I specified some cutoffs in a dictionary format. We saw how to define dictionaries within the series. Let's also define a dictionary of colors. And for background, we're gonna use blue. And for low grade, we're gonna use green. And for the high grade, we're gonna use red. So now let's see how we can use some Matplotlib functions to incorporate more features and customize figures that are generated by RMSP. So if I create a figure, let's say CDF plot for copper, this should be uppercase. So this is how RMSP plot for CDF plot looks like. But we might want to add features to this. So the output of this function is a figure and a axis handle. And as we saw before, we can use this axis handle to add things to the plot. So for instance, I can iterate over name and cutoff, which are available in my cutoffs dictionary. So I can use items from the dictionary. And in here, I can use axis dot xvLine. So this is a Matplotlib function for the axis object. And this function is used to add a vertical line to the plot. The only argument I need to specify here is where in the x-axis that I want to add that vertical line. And of course, I want to add the vertical line at the cutoff value. Other things that I can specify here is a label. So I can give a name to this function, to this line, and the name is going to be the name of the domain in this case. And the last thing that I want to specify is the color, and that's going to be from my colors dictionary for the specific name. So if I run this, it will, I haven't run that cell yet. So if I run this, it will generate the plot, it will add the lines, but even though I labeled the lines, so these lines have a name assigned to it, I do not have a legend yet. So to add a legend to the figure, I just need to do axis.legend, and that will add the legend to the figure. So now I have my lines and I have my legends as well. So that demonstrates how we can use Matplotlib to increment and customize functions that are generated by RMSP. So let's see some pandas operations that we can use within our RMSP object. So we have this composites, which are point data at the moment. And we saw that we can, because this is a data frame, we can do everything that we can with data frames. So in this case, I'm initializing a column on this comps. So if I list all the columns in this data frame, I see that I have grade shell now, but at the moment, the grade shell is all assigned to this empty string. And the idea here is that I want to create a grade shell column with the grade shell flag, which is just going to be based on cutoffs. So let's iterate over names and the cutoff again in dictionary items. So again, I'm iterating over this dictionary, which contains names and cutoffs assigned to those names. We can specify a keyout by slicing or checking my copper data for anything that's above or equal the cutoff value. So this key out is going to be a Boolean array. So for instance, if I want to run this loop real quick, just to have access to this output, what I usually do is I add a break in here. So basically what this does is, like, in the first time it iterates, it hits this break and exits the loop. So if I do that, what I can see is the content of this key out already for that first iteration. And then I can prototype things. So I know key out is a Boolean series calculated from the grade. And I already showed that we can apply things like sum to the key out. And this basically tells me how many composites are above this cutoff, which is currently 0, because that's the cutoff of the first domain, which is background. So for instance, I could print this on screen by adding, say, there are, and then my key out, and then let's format it in some ways so it looks good. And then we can say in the name records. So we are saying that there are this many data in the whatever name it is in that loop record. So we can print that on the screen. And lastly, of course, I haven't done yet anything with key out other than reporting on the screen. We can actually use that to assign to my grade shell. So grade shell, the name. So whenever this condition of the key out of the cutoff is met, I'm assigning the name of relative to that key out to my grade shell column. And if I do that, there is a error here, and that error is here. There you go. So as it loops through my cutoffs dictionary, it will report how many data was found for that above that cutoff, and it will assign to that column. So now if I check the column and do, say, a unique and look at all the unique codes, we now have empty for when there's no grade, and low grade for when it's the low grade cutoff, high grade when it's high grade cutoff, and background when it's background cutoff. So let's add this to this cell and move to the next one. So I just demonstrated some pandas operations that we can use with the RMSP point data object, because it's also a pandas object. So let's now create a figure so to visualize what we just created. So let's do fig axis equals plt.subplots, and I want 2 rows and 1 column, and fig size is gonna be 7 by 9. And that's all. So let's see what it looks like. I made a mistake in here. Big size. All right, so there is a typo there. Okay, so it created 2 axes, and now we can add things to those axes. So let's do something a little different. So let's use a for loop for columns and axes, and that's gonna be coming from a zip, which is going to combine the 2 columns I want to visualize. So the first one is copper, and the second one is grade shell. And of course, I want to zip this with my axis. So I have 2 axes and 2 columns, and if I zip them, I can combine them in the loop. So I have access to the column and the axis. Let's do axis here, enter. And let's create our section plot. So comps.section plot, and it takes the column and it takes the axis. So let's see how it looks like. So this loop is iterating over the columns and axes and adding copper to the first axis and the grade shell to the second axis. So what you might notice here is that our grade shell is getting some default colors. The default colors within RMSP follows the tab 20 Matplotlib, which also matches codes like C0, C1, C2 which represents this blue, a orange, a green, and I think the next one would have been red if I had another category. But I do not want to use the default. As you may recall, we defined the colors here, so I want to use these colors. So somehow I need to specify to this function that I want to use those colors when plotting a grade shell. So one way of doing it is saying, of course, we need to specify the CMAP, because the CMAP is what controls the colors for the variables. So CMAP is equals CMAP, and now we need to define CMAP. So if column equals grade shell, I want the CMAP to be colors, and then otherwise I want CMAP to remain as known, so the function will use the default. So I can run that, and it already have the behavior that I want. So I'm seeing the correct colors now, and of course copper hasn't changed, because for copper we are using none because this doesn't match. The last thing I want to talk is we can simplify this actually, and we haven't looked into that yet. So I can do CMAP equals to colors only if the column is equals to grade shell. Otherwise, CMAP should be known. So this line of code does the exact same thing of these 4 lines of code. So I can actually remove this and run, so this will have the same effect.